especially if they are interconnected. That one, the pollutant will just go through the spaces and then end up in the groundwater system, and then it gets the groundwater polluted. So you have to also keep this in mind. Another thing is that confined aquifers tend to be better. They are able to protect. Confined aquifers are much more protected from pollutants than aquifers that are unconfined or sometimes even semi-confined. And you can see the picture. The one on the water that is on top, that's the blue color. Then let's see, that's the water. The one on top of the clay layer is what a semi-confined aquifer. Semi-confined aquifer. So if you tap from that area, it can be easier to be polluted. But when it gets to the region of the confined aquifer, you realize that there's a confinement below that ash color, below the blue water, below the clay. And the clay too above the confined area also serve as a barrier that prevents pollutants from getting into the water below. But one thing that we have to also notice is that should a well get through the unconfined area to the confined area, it is likely to pollute the water at the confined area, because the water will move from the unconfined area, which is already polluted, and then get inside the one with the confined area. So it is not advisable to drill wells within the same aquifer system. So normally what the advice is that wells should be between the 50 meters to 100 meters, the spacing between wells to be around that area, so that the likelihood of getting inside the same aquifer system may be prevented. But sometimes, who knows? We are not inside the earth and we may not know. So it is very, very important that we get a professional who will do some of these things and analysis to help us in this work. So if it is only within the unconfined area, the confined area is protected. But if it casts across the unconfined and gets inside the confined aquifer, then that one, the pollution is highly likely. Now, this thing, I think I've talked about it in our previous videos, and I would like to talk about it again. We have the water cycle, where we have the clouds which becomes heavy and then they fall as rain, which we call precipitation, and there's runoff that goes on the surface, but the one which enters the ground, which we call infiltration, then gets to the and then percolate at a level, is also there, and then it gets into the groundwater system, and then at the water table, the surface water, some run into lakes and reservoirs, and then they get back into the sea, and then there's evaporation, the water condenses, and then they form the clouds again, and then it gets to the cloud becomes heavy, and the cycle restarts again itself. So this is the water cycle or hydrological cycle. That's the technical name. Now it's the same thing here: condensation of the clouds, and then it falls as precipitation. There's a runoff, and also there's infiltration and percolation. The water gets into the lake too. The water flows into rivers, and then the percolated water also gets into the ground system and forms groundwater. And then there's a discharge through capillary rise. And then the water gets into this. The plants also get this water from the soil, and then they transpirate. And then the ocean also evaporates, and then we have evapotranspiration. Yeah, and then this evapotranspiration forms the clouds again. The clouds becomes heavy, and then they move to the surface of the earth, and then the cycle starts again. And it's the same thing here. So now when there's rain, now as I mentioned, there's water that gets into the the groundwater system, and what happens is that um this water this water system, what happens is that they get into the earth, and some have comes up as um, gets into the streams as a result of capillary rise, and then some too move from the spring and gets into this water, and they end up in ponds and all that. So these are some of the things that we have to note. The water table is usually like a subdued replica of the land surface, as I've mentioned it already. Streams, rivers, ponds, and marshes are intersections of the water table with the land surface. So if there's an intersection, it forms a spring, you know, intersection between the groundwater and then the this thing, the streams and all that. There's a spring that can be formed. So groundwater usually moves in the downward slope direction of the water table. Now groundwater also discharges into these streams or into the ocean as what? As a result of capillary rise. So we have to have that. We can see this picture here on the left, and this picture here has, if you look at it, it has some cream colored shaped particles or something, structures, and then there's a whitish background. When it comes below it, there's this blue background in it. So where there's a white background, um that means that there's the cream structures are particles, or yeah, the soil particles. And when you look at them, the white background means that there's nothing, there's only the particles that are there. But where we have the blue colored thing, those are water. Those are waters that have been poured into this container. Let's call it a container. So where there's no blue color, well, there's no water, we call that space zone of aeration. So zone of aeration where there's spaces in the rock, there are spaces in the rock and there's no water in that area, in the rock or the soil structure, the soil which has no water. And then we have where the water is, that's what we call the zone of saturation. Zone of saturation is where the pores are filled with water, you know. And in between we have what? The water table. So that's the boundary between the zone of saturation and the zone of aeration. So the well must go below the water table to reach the groundwater. So that is very, very important. Now, when you look at this, you can see this structure to that creamy colored and some getting into brownish and all that. You realize that the water, there's these spaces between them, and the water can flow through those spaces. So that is what we are coming to look at, something we call porosity and what? Permeability. It's very, very important thing that we have to look at. Now, when we talk about porosity, it's just the spaces in the rocks or the soil particles where water can flow. You know, that's it. That's the basic understanding of porosity. You know, so technically we may say there's the percentage of materials volume that is pore space. I mean, the spaces between it. Now, permeability is the ability of the soil material or the rock to allow water to go through it easily, or the material to allow water to go through it easily. Now, when we have bigger particles, you know, and they are not regularly shaped, what happens is that they cannot lock themselves up. So the spaces in between are very massive, and that they are very, very porous, and they can be very permeable. Now, so that refers to the picture on the left. The picture on the right too, you can see that there's this granular. When we say granular, it means that they are big particles, granular particles. Those are big particles, and then we have smaller particles. That's finer particles. So if there's a mixture, the finer particles block the spaces. So you see that yes, the porosity may be there, the permeability may reduce because the smaller particles will fill the spaces in between. So that's it. We can see typical that of it here. So you see that on the far left we have materials that are interlocking, that have closed out the space. So there's no pore spaces in between. So it means that that part is not porous, it is not permeable. And then we have one and the middle portion where the pores are not connected. And if they are not connected to, the flow of water becomes very, very difficult. So it can be porous but not permeable because of the pores are not connected to each other. But where the pores are connected, you realize that it is porous and permeable. The water can flow through it easily, So you have to understand that. So now let's come to the proper thing, well, and how it is done. when you drill a well and all that. So, or groundwater or borehole, you know. So this is basically things, the activities that take place during a borehole work. You do your preliminary study, which